Hello, welcome to Chapter 1, Lesson 6, Measuring Angles. Angles, angles, angles. We have one definition here. You'll get more later, don't you worry. An angle is formed by two rays of the same endpoint. When you have an angle, the rays are considered the sides of the angle, so ray, ray. And the endpoint is the vertex of the angle. So this endpoint here of our two rays, that is called the vertex of our angle. You see this little symbol here? This little symbol, this means angle. So when we write out different equations in math, if you see this symbol, that's shorthand for angle. This angle here in this diagram, we can refer to this angle as angle C, angle ACF, angle FCA, or also angle 1 because of this 1 here inside the angle. There isn't a standard way of referring to any one of these, or there isn't a standard way of stating this angle. Either way you want to do it is fine. We can measure angles with degrees. When we do it, we're going to write it like this. This is shorthand for the measure of angle ACF, which is equal to 80. Again, I know that this angle measure is 80 because it says 80 degrees inside of here. And again, we read this measure of angle ACF. All right, here we have the protractor postulate. This is very long. Still important for us to know. What this says, basically, as you write this down, this basically says that for any angle, we can give it a measure. And we can actually find it using a protractor. We'll look at that much later. But basically, if you have any angle, we can find the angle measure of that angle. That's what this protractor postulate is telling us. It's very similar to the ruler postulate back from the last section, postulate 1.5. We are able to classify angles according to their angle measure. If the angle is between 0 and 90, not including 0 and also not including 90, that's considered an acute angle. A right angle, that's when the angle measure is 90 degrees. An obtuse angle is when the angle measure is between 90 and 180, not including 90 or 180. And then also a straight angle. A straight angle is when the angle measure is exactly 180 degrees. It'd be helpful for you if, along with the name of it, you have where the angle measure falls in between, and also a small little picture will help you as well. Postulate 1.8, that is the angle addition postulate. And what the angle addition postulate tells us is that two things. First, here we got point B, and that's in the interior, so it's inside of an angle, AOC in this case. Then the measure of AOB plus the measure of angle BOC is going to equal the entire angle measure, AOC. So each adding up the angle measures of the two parts is going to give us the whole thing. And then over here, if AOC is a straight angle, then we know that AOB plus BOC has to equal 180, because we know that this is a straight angle, it's 180 degrees, so the two parts have to add up to 180. That's the angle addition postulate. There's four types of special angles. The first one here is vertical angles. And those are two angles whose sides are opposite rays. So 3 and 4 are vertical angles, 1 and 2 are vertical angles. Over here we have adjacent angles, two coplanar angles with a common side, a common vertex, and no common interior points. Those are adjacent angles. Complementary angles, those are two angles whose sum add up to 90 degrees. Supplementary angles, their measure of their angles, if we add them together, we get 180 degrees. This part is important. Write this whole part down. I know it's long, but this part is important. It says that whenever you draw a diagram or use a given diagram, you have to be very careful. You cannot assume that angles or segments are congruent. You cannot assume that an angle is a right angle, and you can also not assume that lines are parallel or perpendicular. You can assume that they are adjacent supplementary angles, and also vertical angles. We will go into this more with our examples, and my 5 minutes is up.